In this video, we'll be going over the for statement. The for statement, or sometimes called the for loop, repeatedly executes a block of code until a condition is no longer satisfied. The while and do-while statements for looping can accomplish similar tasks as a for statement, but a for statement is more suitable when you know exactly how many times you want to execute a block of code. There are two ways of writing a for loop. First, I'll go over the basic for loop, and then I'll introduce the for each loop. But first, I'll motivate the need and usefulness of a for loop. Feel free to use the timestamps in the description below to skip over and directly move on to the structure of for statements. Suppose we have a static method for calculating the percentage interest of a certain amount. We simply pass in two double variables. One will be the amount, and the other will be the interest rate. Using these two arguments, we'll return the calculated interest. If we want to compare 5,000 at 0, 1, 2, 3, and 4% interest, we could call the method 5 times sequentially, but this can get very tedious when we have to do it a lot of times. This is where looping comes in handy. We can get the same result as we do here using a for loop. The basic structure goes like this. We type in for, and then within parentheses, we have these three statements separated by semicolons. The semicolons here are very important. It defines the end of each statement and the beginning of the next one. The first statement is code that we execute once before the code block is executed. It's usually used to initialize a local variable, which we can use as the counter. The second statement is the conditional statement. It defines the condition for executing the code block and tells us at what point we terminate the for loop, exit this block of code, and continue on with the rest of the code after the for statement. If this Boolean expression evaluates to true, we iterate the code block again. Once it evaluates to false, the loop will terminate. The third and final statement is the iterator, or the iteration step. This expression is executed after each iteration of the loop. It's usually used to update the counter by either incrementing or decrementing the variable initialized in the first statement. We will fill the code block with the code we want to loop or iterate over. So when we put this all together, before the first iteration of the code block, we initialize a counter and we only execute the statement once. After every iteration, we execute the iterator statement and then check the conditional statement before deciding whether to iterate again or terminate the for loop. It's simple enough, but it might not be completely clear. So, using this guideline for the general form, instead of explicitly calling the function calcInterest a fixed number of times, we'll use a for loop that does the same thing and returns the same output as seen in the terminal here. To do this, we'll initialize our counter I to 0 first. We can use this counter as the interest rate. Our condition is I less than 5. This means I can be any value from 0 up until and including 4, but as soon as we hit 5, we terminate this for loop. Our iterator will be to increment I after each iteration of the code enclosed within the code block. Within this code block, we'll create a double variable, interest, which we assign to the value of the counter I. This effectively casts the counter's integer value into a double value. We need interest to be of the double data type because this is the data type that the calcInterest method specifies for its interest rate argument. We can now call the calcInterest method in the print statement as we did before, but instead of specifying the exact value for the interest rate argument, we can simply pass in the interest variable. When we run this code now, we see that the output is exactly the same as before. The only difference is that the code used to produce this output is less repetitive and thus less prone to bugs. If it's not immediately clear to you how the for loop does this, I advise you take a few seconds to pause this video and understand what's going on in the code from how I've told you the for loop functions. In the beginning of this video, I said there were two variations of the for loop. The one we've just seen now is the basic version, used for general purpose. The for each loop is another variation, which is specifically for looping over arrays and other collections. First, I'll show you the structure of a for each loop, followed by an example. But please watch till the very end because it's important to know exactly when to use which variation of the for loop. I'll tell you the difference between the two loops and when to use which one. The general structure of the for each loop is as follows. You start with the for keyword, and then within parentheses, you specify the data type of the elements of the collection, followed by what the elements of the collection represents. Then, after the colon, we specify the collection we are looping through. Finally, using curly braces, we can start the code block which will contain the code we want to execute for each element in the collection. One thing to note here is that there is nothing that accounts for the index number. We just sequentially go through the contents of the specified collection. If we wanted the index, we could do this using the traditional for loop. Before I start to explain the for loop equivalent of this for each loop, you could skip through this bit using the timestamps in the description below, but it might help with your understanding to know this bit and help you choose when to use which version. The for loop equivalent of this for each loop would be as follows. The counter will start at the 0 index. The condition for terminating is when we've iterated over the length of the array or the collection, and after each iteration, we increment the counter and look at the next index. Within the code block, we can then use this counter to access the value in the ith index of the array. Here's an example of how the for each loop works. Say we have an array of names where each element of the array represents a name. So for our for each loop, the type is string and each element represents a name followed by a colon and the name of the collection we are iterating over. In the code block, I'll just write a simple print statement that says hello to each person's name. After saying hello to everyone, we can have another print statement after the for each loop. So this code will go over each element of the collection, executing the contents of the for each loop. Once it's covered the whole length of the collection, it will terminate and exit the loop and continue on with the rest of the code, which in our case is just a single statement. As promised, now we'll go over the differences and when to use which variation of the for loop. There are really two things that you need to be aware of. The first is that for each loop is for read-only purposes. This means you cannot modify the collections within this loop. However, with the for loop, you can modify the contents of the collection. By modify, I mean change the element at the index, or remove or add elements to the collection. So naturally, if you need to modify the contents of the collection, then you'll need to use the traditional for loop. But if you just need to search a collection or go through the whole collection, then the for each loop is a more elegant option. Another main difference is that for each loop is used when you aren't concerned with the index of the element. If you do require the index, you need to use the traditional for loop to keep count of the index using the initialized counter variable. Other than that, it really is mostly about style and preference. I hope you found this video helpful. Thank you for watching. Please like and subscribe for more videos like this. Comment with any suggestions or recommendations for future topics.